Hello people, welcome to Night Out Notes. In the previous video, we'll understand what is scheduling and serializability in DBMS, right? In today's video, we'll understand what is recoverability in DBMS. Recoverability is mainly used in scheduling. Scheduling only tells us the order of operations which the transactions are executing, right? And recoverability tells us whether the execution order is safe if transaction fails. There may be chances of transaction failure, right? The order of execution is safe or not, the recoverability will check. Serializability checks whether the order is correct and recoverability checks whether the order is safe when failure occurs. Recoverability is simply another property of scheduling, we can say that. Recoverability is an ability of a database to recover schedule from transaction failure while maintaining database consistency. In this recoverability, we are recovering the transaction failures. There may be some chances of failures in the transaction, right? So we are recovering those and making the database to be safe. This is mainly used to prevent data consistency. Everywhere the data need to be same. Like after the transaction, once it committed only, the data need to be updated, right? The updated data should be same in every database. Handles transaction failures. If any failures happens inside the transaction, then it can be rolled back into its existing state, its original state, and it will perform only the operations on that original state only. Maintains database consistency. The same like data consistency, prevent data consistency. It's like the same thing. Ensures reliable transaction execution. Reliable is nothing but we can trust the process. Like always the same execution process will happen. No new process will come into that. We are having 5 types of recoverability: recoverable schedule, non-recoverable schedule, cascading rollback and cascadeless, and strict schedule. First, we'll go through this recoverable schedule. If a transaction commits only after the transaction from which it has read commits. It says that when a transaction is depending on another transaction, the first transaction is committed only, then only the dependent transaction will be committing. Like for example, let's consider these two transactions. We are having T1 and T2 here, right? So, we are having initially A value as 100 rupees. Here A was readed and then write A is equals to A minus 10. So, here the value will be 90, right? So, after this, this writed value only will be read in this T2, right? This is dependent on this. So here read of A will become 90. After committing this whole transaction only, this will be committed. So that any transaction changes happen inside the first transaction will be dependent on this, right? So the changes will also be dependent and changes also will be getting into this first transaction to second transaction. So this can be called as this recoverable transaction. In this, a dependent transaction, here the dependent transaction is T2, this thing is depending on this, right? Should be waiting for the first transaction to be committed. Then only this can be committed. First this transaction will commit. After this committing only, this another transaction which is depending on this should be committed. Before it cannot be committed. This happens like this, we can say that the schedule is recoverable schedule. Next we'll go through this non-recoverable schedule. If a transaction commit before the transaction from which it has read data commits. Like in the previous schedule, we saw that the dependent transaction should always wait until the first transaction should be completed, right? Here it is opposite to that. It does not wait for the dependent transaction to commit first. It will commit by itself only, like see. Here we are reading A. Here also I am taking the A value as 100 and we are reading A and writing and we are writing an update as A minus 10. Like it will become 90, right? So here it is reading. It is a dependent thing on the T1 transaction. T2 is dependent on T1. So R of A reading will become 90, right? Transaction 2 got committed, but suddenly transaction 1 got failed due to any system failure or anything happened inside that, and it got rolled back into its original state and the A value became 100 only. There is nothing change like what's happening in this will be rolled back into the existing position, right? So nothing change will be happen. But the T2 is already committed here, right? In this case, the database will have the incorrect information. Here the A value is 100 and here A value is 90. This double values are there, right? So incorrect information is stored inside that. In real life, we can say that a person A is writing his answer sheet and person B is trying to copy his answer sheet from the person A. Suddenly, person B go to the invigilator and submit his answer sheet. But person A got some new answers, like he thought that the existing answers are wrong. He is willing to change his answers. So person A will be changing his answers to X to Y. Here person B cannot change his answers, right? So he already submitted this thing. This is what happens inside this non-recoverable schedule. This is why non-recoverable schedule is not preferable in DBMS. Next, we'll go through this cascading rollback. When the failure of one transaction causes multiple dependent transactions to roll back, it is called as cascading rollback. Here, one transaction failure will lead to multiple transactions to get rollback. This is what this cascading rollback says. This will be very much worse than this non-recoverable schedule, because T2 is dependent on T1 and T3 is dependent on T2. When T1 fails, all these transactions need to be rolled back, right? See, here we are writing A. Let's consider this A value as 100 right now, and we are performing some operations, right? A is equals to A minus 10, 90 will be there. And then we are reading A. Here reading A will become 90. And this is dependent on this thing, right? And after this, we are writing B. We don't know whether the B value is anything. We are considering this B value as 90. Here B value is equals to 90. We are performing some operations here. B is equals to B minus 20. So it became 70 here. T3 is dependent on T2, right? So the read of B will become 70. Due to some system failures, the T1 became failed. So this became roll back to its existing state, its original state. So it forces T2 and T3, like dependent operations, to roll back to its original state. Like it forces it. This leads to the CPU maintenance also. Here CPU will take the data into it, and also it will lose its data and roll back into its original state, right? So CPU transaction data will also have affected due to this thing. And in real life, we can say that suppose a teacher enters wrong marks into the examiner, like Excel sheet. Another teacher prepare a rank sheet. Principal also prepare merit certificates based upon those marks itself. Later teacher corrected his marks. Then all those things need to be rolled back to its original position, like the merit certificate need to be changed, and then the rank sheet need to be changed. Everything depending on that mark should be rolled back into its original state. This is what happens in this cascading rollback. Next, cascadeless schedule. Schedule is cascadeless if a transaction reads data only after writing transaction commits. Here in first transaction, after writing any operation in the first transaction, it will get committed only. Then the transaction 2 can do it operations like read operations in that thing. This is what the cascadeless schedule will say. Here see, after writing the first transaction, any write operations in that first transaction, it will get committed. After that only it can read. Like here we are having some issues, like see here in this transaction 1 and transaction 2, if there is any read operation and read operation here itself, there is no need of committing here. And also write operation and write operation also, there cannot be need of this commit operation. This commit operation is only needed when the write operation is performed in the first transaction and it is dependent on the second transaction, then only read operation is performed. In only such cases, cascadeless schedule can work. Like we can completely avoid the cascading rollback as compared to the previous one, right? So we can completely avoid that. But only in this case, writing operation after that committed, only read we can do. We cannot do this read and write. This cannot be possible in this situation. To overcome those problems, we introduced this strict schedule. If no transaction can read or write a data item until the transaction that last wrote is committed or rollback. In this we can say that T2 cannot even touch the T1 until T1 commits. Like no reading or no writing can be done in the T1 until T1 finishes the whole task itself. Like see here. In this T1, the write of A operation is committed only. Then only the T2 started its operations like read of A and write of A and commit. If transaction 1 was not committed, transaction 2 cannot perform any operations in this. So, scheduling decides when transaction needs to be executed, and serializability checks whether the transaction order, execution order is correct or not, and recoverability checks whether the schedule can recover from its failure state or not. Yeah, this is all about recoverability in DBMS. Hope you like this video. Until then, don't forget to hit that bell icon and subscribe to my channel so that you'll get more informative videos like this. If you found this video really helpful, please like and share. Meet you in another video. Bye bye.